Okay, good morning. Okay. So today we want to start the fourth module. Okay. So mm, today we want to start the fourth module, and in the third module we discussed the various uh, traversal graph algorithms, graph-based algorithms. Okay. Which are the algorithms? BFS, DFS, then mm, strongly connected component concept, then shortest path algorithms, okay, then connected component concepts also we discussed. Okay, so today we want to discuss uh, hello. Okay, and today we want to discuss today we want to discuss uh, the fourth module. Okay, so in the fourth module, the first part of the fourth module is based on the divide and conquer approach. Okay, so you already know what is divide and conquer approach. Based on that, we want to discuss some algorithms. Okay, so that is our first focus. Then we want to discuss some other topics. Okay, so what is divide and conquer approach? You already know what is divide and conquer approach. So the basic concept is if the problem is complex, then what we will do? We will divide the problem into various sub-problems. Okay. Sub-problem means size smaller than the original problem. In this way, we will divide the problem. In this way, we will divide the problem. In this way, we will divide the problem into small sub-problem and we will solve the problem. Okay. So, and this is the approach we want to use in the divide problems. Anyway, so in the first part we will discuss. We'll start from here. Wait. Okay.
No, ma'am. I think Deepika ma'am left. I think she is joined back. Just a minute. Let's check.
Hello. Okay. So we are starting the module 4. Okay. I hope everyone can see the screen. Okay. So we are starting from the module 4. Starting in module 4. So module 4, in the first we discuss what is divide and conquer approach. Okay. So what is divide and conquer approach? Already I told we will divide the problem into small and small sub-problem. Then we will solve each sub-problem. Then we will combine. Then get the final solution. That is the approach we want to use. Okay. So a divide. So we can define divide and conquer approach in this way. Okay. Given a function to compute n inputs. Okay. Given a function to compute n inputs. Okay. Given a function to compute n inputs, the divide and conquer strategy suggests splitting the inputs into splitting the inputs into k distinct subset or subproblems. Okay, subset one less than k less than or equal to n, and which yields or yielding k subproblem. K subproblem. Okay, so next, if the subproblems are larger, then recursively apply divide and conquer to subproblem. Okay, so we will divide the problem into subproblem. If the subproblem is still larger, then we recursively divide and we recursively use divide and conquer approach to the subproblem. Hmm? And combine and then combine all subproblem. So this is about the divide and conquer approach. So in the university exam, they asked what is divide and conquer approach. Okay. So next topic is there is a small topic, control abstraction. Okay, control abstraction. So basically, we want to write that approach, divide and conquer approach, in the form of an algorithm. Okay. So suppose this is the problem P. The P is the problem to be solved. Okay, using divide and conquer approach. So I written it as DNC. Okay, DNC. So this is P. Okay, P is the problem to be solved. Next, we will use divide and conquer approach, and the control abstraction, or the control abstraction is, this is the format of solving problem. In the first part, you can note here, this is the base condition. Okay, this is a recursive algorithm, and of which this is the base condition. So if the problem is very small, then return S of P. S of P means P means solution of that problem. Okay, so if the problem is very small, then return the solution. Okay, this is basically, this is a recursive algorithm. Okay, so this will be the base condition. This is the base condition. Okay, this is the base condition, and the else part contains the general solution, general condition. Else, what we will do, divide P into smaller instances P1, P2, etc. Pk, where k greater than or equal to 1. Okay. Then apply divide and conquer to each of the subproblem. Okay. First, we want to divide the problem into smaller instances P1, P2, etc. Pk. Then apply DNC, divide and conquer approach, to each of the subproblem. Okay. We want to apply the divide and conquer approach to each of the subproblem. Then next is at last, what we want to do, we want to do the combine step. We want to combine these, that is, combine the subproblem, combine the solved subproblems into one, that is this is the control abstraction, or this is the format of solving this is the format of solving divide and conquer approach problems. Okay, divide and conquer approach problems. Okay, so basic concept is very simple. Basic concept is very simple. Okay, basic approach is where this is the basic approach. So this is also a university question. Okay, that is why I am discussing this. Explain the control abstraction of the algorithm, or of the divide and conquer approach. Okay, so this is about the control abstraction. So basic concept is very simple. Uh, Basic concept is simple. That is, P is the problem to be solved. We will check whether the problem P is small. Okay. If the problem P is small, that can be solved in a, very easily. Then we will solve that problem and return the solution. Okay. So else what we want to do? We want to divide the problem P into smaller instances P1, P2, etc. Pk and k greater than or equal to 1. Hmm? So these are all sub-problem. P1, P2, P3, etc. sub-problems. That is what is meant by sub-problem. A problem with the input size, less size. Okay, so there were P1, P2, etc. Pk. Then apply D and C to each of the sub-problem. That is, apply divide and conquer approach to each of the sub-problem. Okay, so we will apply the same approach, recursively apply the same approach. We will divide the problems then this way. Okay, so this is the second. Then after the final step, what we will do? We will combine all the solutions. Okay, we will combine all the solutions and form the final solution. Okay. This is about the control abstraction of this problem. Okay. So what is divide and conquer approach and what is the control abstraction? Okay. So which type of problems we can solve using the divide and conquer approach? Uh, there are several problems. Here there are merge sort, quick sort, similarly binary search, etc., etc. We can solve towers of Hanoi. Okay, this is another problem. These problems we can solve efficiently using the divide and conquer approach. So now we are going to discuss the classical case of merge sort. Okay, so the in the syllabus there is, we want to discuss two-way merge sort. Okay. Two-way merge sort we want to discuss. Okay, so I'm taking that example to understand here. Okay, so 1 minute, please wait 1 minute. Okay, okay. Next, we want to discuss the working of the merge sort. Okay, so what is merge sort algorithm? Merge sort means it is a sorting algorithm. So what is sorting? You already know. Okay, we want to arrange the data in ascending or descending order. That is about the sorting. Okay. So there are different algorithms. There are different algorithms. Here we are using merge sort. Okay, so this is the merge sort approach. Okay, so suppose this is the array. Okay, this is the array and this is the first item. I'm indexing in this way. Okay, 3, 4. Okay, these are the position. Then what we want to do? We will first divide the problem into sub problem. Okay, based on the mid value. Okay, so here in this case, first we find the mid value of this array. What is the mid value? It will be 5. How many elements are there? 1, 2, 0, 1, 2, 3, 4. So this will be the mid value. So this is the mid value. Then we will divide it into two. One is 15, 5, 24, 8, 1, and another is 3, 16, 10, 20. Okay. So we will divide the problem into in this way. Okay. Next, what we will do? We will again divide based on the mid value. So here the mid value is 24. This is the mid value. Based on this, I will divide this in this way. Okay. So then 15, 5, 24. This is 8, 1. So I'm doing dividing step. Okay. Similarly, I can divide this also. Okay. I can divide this also. So which is the mid value of this? It's basically we will do in this way. 1, 2, 4 items are there. Okay, anyway, we divide. So this will be taken as the mid value. Then 3 and 16, then 10 and 20. Okay. So we will again divide this. Okay. This is a, we will again divide this. So this is the mid value. Then this is 15, 5, then this is 24. Similarly, we will divide it again. Okay. If we divide this, then it will become 8. It will become 1. Okay. If we divide this one. Okay. So here the further division is not possible. Then what we will do? Similarly, this is 24. Further division is not possible. Okay. Now, similarly, we will divide this 15 and 5. Okay. 15, 5. This also in this way. Then we will divide 3 and 16. 3, 1 element, 16. Okay. Then 10 and 20 is divided in this 10, 20. This is about division. That is, we will divide the problem into small sub problem until a single element exists. So here you can note we reached here 15, 5, 24, and then 8, 1, 3, 16, 10, 20. Then we will start combining. Okay. Then we will merge. Okay. So first we will merge this and this. 15 and 5 is merged. Okay. So during merging, what we will do? We will sorting. Okay. We will perform sorting also. That is 15 and 5. Then it is combined at the same time sorting also performed. So 5 and 15 compare. Okay. Then we will combine this. Hello. Hello. Any problems? Hello, Anaga. Is there any problems?
ಇಲ್ಲ ಸರ್
Okay. One minute. So so this is combined and 5 and 15. Okay. Then what we will do? We will combine this and this. Okay. This and this is combined. Okay. So this is conquer step. Okay, we divide the problem. Now we are combining. Okay, while combining here or while merging here, we will perform the sorting also. Okay, 5 and 15 here, then it will become 5, 15, 24. Okay, now this is also finished. Then what we will do? Then we combine this and this. Okay, this and this is combined. Then we will get a 1, 8. Okay, then this is combined with this one. Okay. So we will get this. Okay, so okay, so this is the array. Okay, so after combination 1, 5, 8, 15, this is also in sorted order. Then this is called merging. Okay, then what we will do? We will not here, we will combine this and this. Okay, then we will get a 316. We will combine this 316, then 10 and 20. Okay, we will combine this. Okay, then we will get this. Then we will combine this and this. Okay, then we will get this. Then we will combine this one and this one. Okay, not here. This one and this one is combined. This one and this one is combined and sorted. Okay. Then you will get the final sorted. So in this way we will do the merge sort. So this is called a two-way, because in the first pass what we will do, we will divide the problem. Okay, so we will divide the problem into small problems. Okay, you can observe here, this is the actual problem. We divide the problem into in this way. Okay, we divide the problem in this way. We divide the problem in this way. Okay, based on the mid value we will divide it. So here mid is 1, so we divided in this way: 15, 5, 24, this one. Okay, next what we will do, we will divide this one next. Okay, so if you divide this one, then it will become like this. So that is, we are following, at first we will divide the problem into small sub problem. Okay, then we will divide in this way. Okay, then we will divide it in this way. So this is called division step. Okay, divide step, that is from top to bottom we will divide the problem. Then what we will do, in this way we will divide all. We will also divide this one. Okay, in this way we will divide. Then the next is combine. Okay, after division is completed, we will combine. Okay, we will combine the sub problems. Okay, so we will combine this one, this with this, and we will get, in this way we will combine. Okay, so this is an example of divide and conquer approach, merge sort. It is called a two-way merge sort because in the first pass we will divide, in the second pass we will merge. Okay. So that is why it is called a two-way merge sort. Okay. Next, we want to discuss the algorithm. So, okay. Next, we want to discuss the algorithm, then the working also. Okay. So, just I'm going to the structure of the algorithm. So, this is the merge sort algorithm. Okay. This is the merge sort algorithm, and here the merge sort algorithm consists of two variables. Basically, we are using two variables, low and high. Here, low and high is the parameters to this algorithm. Low and high is the parameters to the algorithm. Then we are basically, there is an array A. On that array, we are performing the merge sort. There is an array A. On that array, we are performing the merge sort. So the parameters are low, high, and A is considered as a global array. Okay, A is considered as a global array. So we don't want to pass that array. Okay. Implicitly, there is an array A. Okay. Next, what we will do? This is the merge sort algorithm. So first we will check if low less than high. Okay, we will check this condition if low less than high. If low less than high, then what we will do? We will divide. We will do this step. That is, we will calculate the mid value. We will calculate the mid value. Mid is equal to low plus high by 2. Here floor function is used. Here we will calculate the mid value. Okay. Here the floor function is used. What is floor? Floor is, suppose 2.5 you got. Floor of 2.5 is 2. Okay. Here the floor function is used. So if the value you got is 2.5, then if you apply floor, it will be 2. Okay. So that's why here floor is mentioned. Then the step is first we calculate the mid value. Then what we will call? We will do. We will call merge sort again. Okay, this is a recursive call. This is a recursive call. We will call this function. This is merge sort function with low and mid. Okay, so current low and mid. We will call this. Then what we will do? We will execute this step. Merge sort of mid plus 1 high. We will call the merge sort again with the parameters mid plus 1 high. In this way, we will recursively divide the problems. Then the last step is merge. Okay, so these are the divide steps. These two are dividing the problem into small and small problems. Okay, then the last step is combine the solution. For that we are calling a function merge. Okay, with the which are the parameters low, mid, and high. Using these parameters, we will call the merge function. Okay. So this is the merge sort algorithm structure. Okay. So this is one more time I'm repeating. So this is the merge sort algorithm. In the merge sort algorithm, parameters are low, high. there is an implicit array A. In that array, the data is stored. Okay, so it is considered as a global array. Okay, so we don't want to pass that array to this function. Okay, so that is why it's called a global array. Okay, now what we want to do, we want to, in the body of the function, first we want to check if low less than high. Okay, if low is less than high, then what we will do, if this condition is satisfied, which means if there are more than one element exist. Anyway, we want to check this condition. If low less than high, then what we will do, we will find the mid value. Okay, so what is mid? Mid is equal to low plus high by 2. Here the floor function is used. Already I told what is the use of floor function. Okay, here the floor function is used. Okay, so based on that, I will calculate the mid value. Then what I will do, I will do the division recursively. So we will call the merge sort algorithm recursively. The first code we will call with the parameter low comma mid. Okay, so you can note here, in the first code we will call with the low comma mid. In the next code we will again divide the problem. That is, we want to divide the problem into two subproblem. Okay, the first subproblem is from low to mid, and the another subproblem is from mid plus 1 to high. Okay, mid plus 1 to high. You can note here. Here basically you can note this only. Okay, this is the problem. Okay, this is the problem, this is our problem. So we will calculate the mid. This is the mid. Okay, this is the mid. Then we will divide this into 2. First we will divide this into, this is basically initially this is low, this is u. Okay, then this is mid, then low to mid. Okay, this is m. So this will consist of low to mid. Low to mid element will be here. Then this is from mid plus 1 to mid plus 1 to u elements will be here. Okay, so this is what this code is doing. Okay, so first we will call merge sort with the low comma mid. Then the problem is divided okay, divided in this way, low to mid. It consists of the low, and that's a problem need to consider low to mid elements only. Similarly, we will divide. Second call is merge sort of mid plus 1 to high. So there are two calls, two division calls. Okay, in this way, this is a recursive call. This will be repeated. Okay, in this way we will divide the problem into sub problems. Okay, again here 2 2 2 2 2 2. In this way we will divide the problem until this situation reaches, that is only one element exists. Okay, then after that we will do combine. Okay, so what is combine means? Merge is the algorithm used for combining. So the parameters are low comma mid comma high. Okay, so this is a merge step. Okay, so these two are division step, and this is a merge step. Okay, this is about the algorithm. Okay, this is about the algorithm. Now we want to study this algorithm also. Okay, what is merge? This is a separate algorithm. Merge means, what is merge means? That is, this is the merge algorithm. Okay, this is the merge algorithm. That is, you can note here, here suppose what is merge function? What is the use of merge function? Suppose this is, I want to combine this and this, then I will apply merge function. Merge function will merge the elements. Okay, the elements in it 5, 15, 24, 1, 8. These are merged and in a sorted order. Okay, that we want to do. Okay, so we want to merge the subarrays into the sorted order. Okay, so that we want to do. So the parameters are low comma, mid comma, high. Then this is the structure of okay, this is the structure of the merge algorithm. This is the structure of merge. Now here. So this is the merge algorithm. So you should study this algorithm also. Okay, you should study this algorithm also. Sometimes in the exams they may ask you explain the merge function. Okay, so should study this algorithm also. Okay, so the working of this algorithm and this algorithm, we can discuss that in the next class. Okay, we can discuss the working of both algorithms in the next class. So this is about the divide and conquer approach. Okay, now we are doing merge sort. We can discuss the remaining portions in the next class. Okay, please give your attendance. Akash Raji. Akash. One minute. Akash absent. Akash. Okay. Okay, next. Akash, Abhinand, Advaith. Next, നിങ്ങൾ ചാറ്റ് ബോക്സിലിട്ടെ അറ്റൻഡൻസ് ചാറ്റ് ബോക്സിലിട്ടോ. അഭിനവ് നെക്സ്റ്റ്. അഖിൽ സി പോൾ. Okay, please give your attendance in the chat box.